I have our induction system off the 2.7 liter, and I'm about to go ahead and disassemble everything out of it. This is often one of the most overlooked parts of an engine rebuild on a CIS engine. There are so many moving parts inside of this system that need to be addressed and cleaned and resealed that a lot of the time people just take the airbox off, sit it off to the side, rebuild the engine, and then put it back on the engine in the hopes that everything's going to function. So one of the things that we do on every engine is our intake manifolds. So this is the injector bucket that seals inside here. There's an O-ring. These are typically rock hard. These are peened in place as well. There's 3 peen marks around them. So with the manifold off, you want to drive this out, and then we've got to re-clean this area, and then when we put a new one in, we want to make sure that we re-peen it so if there's ever a backfire, this just doesn't pop out. There are things like this that need to be addressed. Things also like our intake manifold rubber boots. These do have a life. These ones actually aren't really horrible, but I'm still going to replace them. All of these items need to be checked, cleaned, and replaced or repaired if necessary. So the first thing I'm going to do is just pop things apart, get some of the plate components out since I'm sending stuff out to be replated. Filter's not too bad. Also gives us a chance to look at things like pop-off valves. These were popular at one point for stopping the airboxes blowing up. My personal opinion is they don't stop anything. They just create a leak. These O-rings tend to get rock hard and not seal well. The other thing is you're drilling a hole in effectively a $700 airbox and usually compromising it. I've also seen it where these entire items don't get glued in properly and pop out, as well as a complete backfire. With our sensor plate boot, a couple of things that we're looking for. Usually I'm going to replate all of my hose clamps, and the reason why we replate is not just to make them look good, it's also to protect them. The plating is a form of anode, so it's designed to wear away before the actual plate, before the steel begins to rust. We want to make sure there's no cracks. The boot is nice and soft and supple. This one's got a little bit of oil in it, but not a big deal. It looks like it should be reusable. When it comes to here inside both our throttle plates and our sensor plates, we're going to have to disassemble and clean our throttle housing out. This is a big part of the engine rebuild. You can see just from wear and tear and the closed crankcase system, which means that oil vapors are put back into the intake. There's a lot of carbon buildup around the throttle. This will actually change how the throttle opens and how the idle speed works. So we want to make sure that we disassemble all of this, clean it all really well, make sure all of our air passages are clean and free flowing, and then put it all back together. So that's one of the other items. With our sensor plate, there's a couple of things here that we want to look at. Our sensor plate height, where it sits in this cone, is very important, but we technically can't do that until we have fuel pressure on it. Right now this one is a little low. That will change the fuel curve. Also underneath the fuel head there's a roller bearing that the fuel head piston sits on. That is very important. They can seize up and they can cause the fuel head to chatter. That will make some weird kind of running conditions. So there's a lot of stuff in this system we need to clean up, clean, inspect, lubricate, make sure everything's moving. Just want to make sure when you lift it up that you don't lose your fuel piston. I'm just going to roll it over. There's also an O-ring that we're going to change right here that gets rock hard, just like this one is. So another reason why we want to do that. We don't want to disassemble the fuel head. You do need specialized tooling and equipment to overhaul those, and that's done by a specialist. Down in here, you'll see the fulcrum. I'm just going to lift the sensor plate. So this roller bearing right here is the one that tends to seize up. So we want to make sure that it's rolling nice and smooth, which this one doesn't feel too bad. And we want to also make sure there's no grooves or any marking in there that can get stuck on that piston. But I'm going to pull this off next. So we can see underneath there's some pretty substantial sludge buildup. This will change the way that the plate operates in the car, so it's important that we clean it. Usually I don't completely disassemble these. If they're really stiff on here, underneath these plugs is access to the roller bearings. These should be very smooth. It's only on kind of rare occasions that you need to get in there and physically actually remove this entire setup. Next thing you can see is this gasket, this foam gasket here is completely non-existent, and even to the point on the fuel distributor itself there's only pieces of it. So whoever changed this airbox last did not put another gasket on. Also, these bolts were over tightened. These are designed as a spring with a true pop-off valve, which is what this toilet seat is supposed to be mimicking, where this is actually designed to pop a little bit if there's a backfire to relieve the pressure inside this housing. But the way it was installed, there was no way it could do that. So we've already spoken about the debris buildup here, but the other thing is this O-ring right here. This is what seals the throttle housing to the intake airbox. And like this one, it's very squashed and it's also getting kind of stiff. So if nothing else, we're resealing this surface here, but we'll also be disassembling and cleaning in here. The other thing we want to look at is these hoses. Rock hard. So we'll be also replacing these hoses as well. Anywhere where there's a chance for unmetered air to enter, we want to eliminate that before it gets back onto the engine. One of the other things I want to do whenever I'm doing an engine is have a good look at my wiring harness. So most of these harnesses are 50 plus years old, or 40 plus years old, and a lot of them have had stuff like this. So when you see a football in the middle of the wiring harness, you know you got to pretty much do something about this. Also, you'll see this one where somebody has cut a line. You want to make sure that there's no shorts in there. Often, if nothing else, if you don't want to spend the money to go through and completely redo a harness, just slicing open some of this, especially where you can see it's been retaped, is kind of a must, and seeing what the wire's like. If you have any conditions where you can kind of grab the wire and have it crackle or break, they've still got some flexibility to them. Now's the time to deal with this. Other items that can indicate issues is stuff like this. This is somebody that's connected to the plus 50 wire, which is our starter motor activation. And they've installed a relay, probably because they were having starting issues. This is rarely a good fix. It's more a band-aid or lipstick on a pig. If there's issues with connectivity on the wire or where it plugs in at the 14-pin plug, which is probably going to be this terminal from memory, is the starter terminal, then that's also an indication that you probably want to look at either replacing or repairing your harness. This is going to be installed under the intake manifold, so once it's in the car, it's almost impossible to get to. So you want to take care of any issues that are there and present right now before it goes back together. So I've got most of my manifold stripped down. I've got a few pieces left. These are for a deceleration valve. There's not a lot of checks we can do with these unless the engine's up and running. There's also some TSBs on these available. We want to make sure that these hoses here are in good shape. The availability of this pipe is very limited. There's only really used ones available. If the manifold, if these rubber mounts have failed, and you can see that this one's actually missing one of the mounts, I always replace these. They're very important to the operation of the system. If these mounts fail and the airbox is allowed to drop down, often you can see how there's been some rubbing. This will rub through the aluminum air pipe. So you want to make sure that this pipe is structurally sound and in good shape as well. As when it comes to these are also unique hose sizes. Often it can be hard to replace or rebuild these pipes. It's something you need to just deal with on a case-by-case basis. So this is the air delivery hose to our auxiliary air slide. You can see on this one, the pipe is just starting to go. We've got some cracks starting to form. Where these are usually going to leak is going to be usually right at the connections here. And it looks like we've got a couple of cracks forming right here. So this pipe is something we're going to have to source, see if it's still available, and see if we can replace it. So here's a problem that we see once we get into the airbox. One, this has been over tightened right here, and it's crushed that, so there would have been an air leak. But more so of a problem is they've put the wrong block on. So this one's actually blocked inside. That means that the auxiliary air valve, this part, would have been doing absolutely nothing, and the engine would result in no fast idle on a cold start, which would result in stalling and a bunch of other issues. So just to demonstrate one of the problems with old airbox, this O-ring is like rock solid and would not have been providing a very good seal. I'm so very surprised that it didn't snap when I folded it in half, because it's really hard. So some things that we want to look at when the airbox is apart is, one is these screws. And you can use a screwdriver and very gently, if there's any kind of looseness in these, usually means that the airbox has suffered a backfire and has separated. So you want to just run over them. You don't want to actually retighten them or loosen them. The other thing that you want to look for is evidence of separation along this line. That's very common, where things will get damaged. If this has a backfire, it will actually separate this lower portion from the upper portion. And then inside, if it's the updated airbox, it's going to have this little spider leg network in here, which this is where our cold start injector sprays. And what it actually does is directs the fuel directly down each intake runner, so it minimizes the effect of a backfire. With an old airbox, this was missing, and it would just spray fuel into this chamber here. So if you had a backfire, it was more prone to that airbox being destroyed. So unmetered air, or air coming into the fuel system or through the engine without it going through the sensor plate, is bad for any car, because that means we have air that's going into the engine with no fuel for it. I'm going to check it for leaks. So I'm hooked up to our smoke machine. I'm just going to plug it in and let it warm up for a little bit while we chat. And what we want to do is, I've capped off all of our ports. So here you can see these are just a rubber cap, and I'm using the hose clamp just to seal it off. My connection is in through the brake booster. I have the throttle off this car, so I've just got one of my plugs in there. And then the cold start injector is installed right now, but it is plugged, and this one does not have any hole going through it. So what I'm going to do is we're going to hook up our air pressure to our smoke machine, and we're just going to start looking for any kind of smoke coming out of the intake system. So instantly we can see we have smoke just pouring out of our toilet seat, and it's coming out kind of everywhere, all the way around it. So that's a pretty much instant fail right there. Some of the other areas that we want to look at is the seam where the airbox meets the top portion. And this one we can see we've also got smoke coming out of that seam right there. And there's really no way to fix this. I've seen people try and pull these screws out, separate the airbox and reseal it. It's never successful. The only best way to do it is to replace it. So this is our complete CIS hard parts, all kind of laid out but prior to cleaning. Each one of these parts is an essential part of the operation. We have our fuel distributor right here. This is what controls how much fuel is delivered into the engine. We have our cold start injector. This only works during cranking. Auxiliary air slide. This is what controls our air for our automatic choke. Warm-up regulator. This controls cold fuel running as well as hot running conditions, as well as some enrichment functions, and we'll go into that in a lot more detail later. Our sensor plate. This is how it tells how much air the engine is consuming and transmits that to the fuel distributor. Throttle body, pretty straightforward, allows air into the engine, and these are our intake runners. Now we're getting ready just to clean all of these components up. So I'm going to start with my intake manifolds, and one of the things that we need to do with our intake manifolds is remove our injector buckets. These are the parts that actually hold the injectors into the manifold. Now I've already punched this one free, and one of the things that we have to do is, the way this is held in from the factory is it was installed and then they peened it right here. And you'll see they just punched that rim, and there's 3 little peens. So a couple of things that I have to do is, one, I'm going to hammer this out from the bottom and just knock it out. And I don't care because I'm going to throw that away and I'm going to replace it with new ones. But before I go ahead and do my full cleanup, I need to take my die grinder and very carefully grind off this peen right here. So to remove this, I'm just going to use a small sanding attachment for my die grinder, and I just want to be very careful that I don't actually change this diameter. If I damage this in here, and this is why I use sandpaper and not a carbide bit, is it will not seal with an O-ring. It'll create an air leak, which we don't want on that engine. It will affect the way it runs. So I'm just going to very carefully take these off, bead blast, and tumble all my manifolds. So that's all I need to do is just, you can see I've just sanded that little peen mark off, just enough to where I can slide in the new bucket without damaging the O-ring. So we've got our new airbox, and all we've got to do now to get ready to use this is a couple of small things. These come with this fitting is open, so we're not using a EGR valve on this car. It doesn't have one, so it comes with a plug that we've got to screw in. Then the other thing that I'm going to start doing now is just assembling the basic part of the airbox. So I need to get my intake manifolds. I've got new boots for that. We need to put our cold start valve back in, but I want to test the valve first, and I'll show you how to test those valves on the bench. So we're going to test our cold start injector, and a cold start injector is basically just a solenoid in here and a fuel connection. So I have my little test adapter plug, and it doesn't matter which way you test across the solenoid because it'll still pull the same, so positive or negative doesn't matter. You can also use a 12-volt battery for this test. I'm using our power supply to test it. So I've got my ground hooked up to one, and what I'm going to do is just bring in my power connection, and the first thing, I'm going to hold it really close to the microphone, is I'm listening for a clicking sound, which is the solenoid operating and pulling back. Then the next thing I'm going to do is connect my power and leave it connected. I'm just going to use a little bit of brake clean just to flush through. Where we want to look is right here on the nozzle to make sure we're getting fuel flow, which we are. So normally this injector is hooked up to the system pressure, and depending on the vehicle, that's going to be around 4.5 bar of pressure, so that's about 70 psi. When I go to put the cold start injector in, I've tested it, I know it's working fine. I have my adapter. Now on the early cars, they are not going to use, they're going to use this same adapter, but this will be plugged off so it will not go through. There's an O-ring on the cold start injector that seals here, and then a larger O-ring that just sits in on here. We want the injector plug facing up towards the throttle butterfly, and then we're just going to install our piece. You have to remember too that these are tightening into steel inserts in a plastic box, so we do not have to over torque. We want to be very careful with that. And that's our cold start injector in. Also, we're going to put our brake booster pipe in. So the next thing I'm going to do is set up my intake manifold runner so I can set the airbox on the engine. Once I've got the intakes on, it's a lot easier to assemble our sensor plate, throttle body, all of that stuff while it's on the engine. That way the box isn't kind of floating around on the bench. So first I'm just going to start by pressing on my new rubber sleeves. So if you're not sure where your manifolds go, a good way to do it is just sit them on the engine. So we've already cleaned our manifolds, we've cleaned all of our injector bucket areas. The two manifolds with the M8 studs, these will always go on cylinder 2 and cylinder 3. These are the support brackets for our auxiliary heater fan, although this particular engine isn't running it. For the center ones, very straightforward. They're going to be the ones that have this short manifold, but they're also going to have the mounting point. So this is for the auxiliary air slide on this side, and the one on this side is going to be where our warm-up regulator sits. But a good way, if you're not sure, is just lay them on the engine, then you can take them off one by one. So I've just gone ahead and put on our intake manifold runners, and I've started with this side. There is normally a bracket that mounts right here. What I want to do is I line this manifold up with this rod coming down to make sure that it's nice and flat. And then I get the 3 manifolds attached and making sure everything is nice and plumb. When it comes to putting the other side on, what we don't want to do is load up these rubber joints when they go onto the engine. If we tighten here and then we're tightening here and they're on an angle, say sitting up like that, and we just force it around and into the engine, we'll place stress on those rubber sleeves. So we just want them to be as neutral as possible. So we've completed our airbox, air structures, got our strut, got that installed. The only other thing I installed was this decel valve up here. It installs with the strut. So we're almost ready to put this unit back on, but there's a couple of things that we have to install first. One of them is this air pipe that connects from our adapter on our cold start valve to our decel valve and our auxiliary air slide. So before we put on our auxiliary air slide, we want to test it. Now this component controls our fast idle when the engine is cold. So what I'm going to do is I'm going to take our standard test connector, and what's going to happen inside is this is going to slowly heat up and slowly close. You can see the opening is getting smaller and smaller. And now we are completely closed, so you can't see any light coming through that auxiliary air slide. So this tells us that the bimetallic strip and the resistor that's on it is working fine. We can see our current draw is nice, 0.8 of an amp. There are no real specs on this. And what we can see next, if I turn my power supply off, as that bimetallic strip cools down, it will open up again. Now, when you're testing on the car, if you need to test this unit and the car's already been run, what I would normally do is take the unit off, put it in the refrigerator to cool it down, and it should be completely opened up. These also have very little failure rates. There's not a lot going on in here as far as things to wear out, and I have replaced very few of these in service. And I'm just going to go ahead. It bolts onto the number 5 intake runner, and it's a lot easier to do this before we put it on the engine. The last thing I want to do is just hook up my air pipes, and this is just a lot easier to do with everything upside down. So I have my auxiliary air slide right here. So the first one I'm going to put in is my little rubber connection pipe, and we're going to see this is the air intake for the auxiliary air slide, and it's going to connect to our decel valve up here, and then this goes into our air filter. So this is how it gets filtered air into the system. Then my other pipe is going to be my connection for the outside, or for the air going into the engine. This is going to connect in 3 places. So this is going to connect on here, to the decel valve, and then lastly the way it gets into the engine is on the cold start injection block. So now our airbox is completed enough to where we can put it onto the engine. So we've already got our intake manifold gasket sitting on our cylinder head ports. Wiring harness is all installed, and just our connections right here are just laying off to the side for the time being. So all I want to do is take my airbox, and I just work from one side at a time. On these studs you should use a 12mm width across the flat nut. just to give it enough room for a socket. If you use a regular 13 across the flat, it is a little on the tight side. So now I'm bolted down. These are all torqued. The torque on these is 25 Newton meters. This is my power supply, and I just routed that underneath the intake manifold. I'm going to go and plug that straight in onto my auxiliary air slide. So here on the back of the engine, we're going to have our cold start valve connection, which is just going to plug in like that. We also have here, we can see the rubber mount, which I just screwed into the airbox, so that's just on there. And I've got to put the support bracket here from our fuel line. That's going to connect right here. We'll do that in a minute. Then over here, I've left this outer nut loose because there is a fuel line support bracket that has to go over there. So now our intake manifold is on. I'm going to use this opportunity to put in our new injector buckets. And the reason why I do it at this stage is because they're on the engine. It gives me a nice solid base to where I can peen these in place. So I've got new buckets. I've already put the new O-ring on. I'm just going to use a little bit of silicone grease to lubricate that O-ring. And then I just want to take my thumb and press it all the way in. So I'm just using my brass punch to make sure that these are seated all the way down, because with my thumb I can't get it all the way to seat. Don't need to hit it or hammer it. If you do, you run the risk of breaking it. When it comes to peening these, I'm just going to use a round punch, and these don't have to be huge. That's all it needs is one hit. We can see how the aluminum has just peened over a little, and I'm going to do that in 3 places. So before I put much more of my fuel lines and everything else, I'm going to connect up my breather to the breather plate. This is our oil line. This is going to run over to our oil tank, and it's going to run out through here. And I just want to connect this up now before it becomes a problem later. So now I'm going to start to assemble our sensor plate and our throttle housing onto the airbox. First thing I will do is install our foam gasket. This gasket is sticky on one side and is designed to be stuck down to the airbox. You want to go nice and slow with this, because you want to make sure that the holes are all exposed. And the purpose of this being a foam gasket is this sensor plate is designed to actually lift up and down off of the airbox. So if something does backfire, it does act as a check valve as well, similar to the aftermarket toilet seats or pop-off valves that were installed. Problem is, most people install the sensor plate housing incorrectly, and it can't pop off and release pressure. Take my cleaned sensor plate. Now, this height we spoke about, it's important that we check this. Problem is we can't check it until we have fuel pressure on the fuel distributor when it's all mounted back here. So for right now, what I'm going to do is just set this onto my gasket area. Then the screws that hold these down are going to be Allen head screws. They're going to have a spring and a flat washer. And when we screw these in, what we don't want to do is over tighten. So if this spring is completely coil bound, so if it's screwed all the way down so it can't move, then this sensor plate can't move up and down off its plate. Also, one thing, there is going to be one longer bolt. It's going to be a step bolt. That's going to mount back here or over here. I got to see where my fuel lines. There's a small bracket that holds the 3 injection lines for cylinders 4 through 6. So you need to bear in mind that one of them is going to be a little bit longer. So the way I install these is I screw them down all the way until they coil bind, which is right about there. And then I'm going to back them off half, 1, half, 2 turns. So that way you can see there's room for that spring to move up and down, pop off if need be, and it's not coil bound. So the next major component in our CIS system is our fuel distributor. Now, fuel distributors are a calibrated item, and there is not really a lot that we can do here in the shop itself. Do not disassemble these to take these screws out. They are very specific in the way that this upper and lower sandwich plate is sealed. In each one of these ports is a spring and a series of shims that controls the cracking pressure as well as volume out of each one of these ports. So there is really nothing that you can do inside of these in your own shop, whether it's a professional shop or a home shop. So the couple of things that we can do. Firstly, we want to make sure that our center plunger, our piston, moves freely. And I'm going to go ahead and pull that out. I want to be careful whenever I tip the fuel distributor over that I don't drop this on the ground. Now we can, if there's any signs of scoring on these, we can polish these with a little bit of Scotch-Brite. We just got to make sure it's perfectly clean before it goes back in. When I put it in, it should pretty much slide in there. It's very tight tolerance, so getting it straight can sometimes be an issue. And should move nice and freely just with finger pressure. The other thing that we can do is this is our fuel pressure control valve right here. This is what determines our system pressure. Inside here is a spring and a pin with a piston, and it controls how much fuel goes back to the fuel tank. And we'll talk about this when we have the rest of the system for diagnosis with fuel pressure gauges on it. So for right now, all I'm going to do is we're going to put a new O-ring. This is what seals the fuel distributor to our air mass meter or our airflow sensor plate. I'm just going to press that down like that. So one last check that I want to do before I put my fuel distributor on is down in here we have this roller bearing. And I want to just reach in there with my finger and make sure that this roller bearing moves freely and does not bind up at all, and as long as it moves freely, then I'm ready to put the fuel distributor on. I'm just going to hold my finger on the bottom for as long as I possibly can, line up the 3 bolt holes, and then I just want to drop that in fairly quickly until it sits down. Our cold start connection is going to point out towards the fan, and if we look over on this side, you can see there is a groove cut in the fuel distributor. That is for our 3mm Allen wrench screw, which goes down to adjust our fuel mixtures. So the next item we're going to look at is going to be our throttle body. And I have washed the throttle body. A couple of points to kind of look at. This is our idle air control, and this is what sets our actual idle speed. And this is a bypass screw. I pulled it out for cleaning, and we can see our passageways down inside. And what this does is it takes filtered air on this side of the throttle plate, brings it down past our bypass screw, and allows it to come into the engine underneath the throttle plate. I have washed the throttle plate, although this one has got a lot of staining on it. Typically I don't take the throttle butterfly out of this unless I have a reason to. So this is the throttle plate stop screw right here. Normally I leave these alone. There's usually no reason to adjust it unless somebody's played with it. This one still has the original yellow paint showing that the nut hasn't been broken free and the screw slot's still full. What I need to look for is I need to make sure that I have a little bit of air showing around each side of that throttle plate. I don't want it seated up against the housing. That'll cause it to wear. One of the other components that is normally mounted to our throttle housing, and it will mount right here, has a small spacer and an Allen head screw that screws in right here. This is another adjustable deceleration valve, and I'm going to show you how to test that in just a minute. The way this works is this is mounted right here. This is connected to manifold vacuum, and then this hose will connect into here and also from this port, and then from this port to this port. When we have a high manifold vacuum on deceleration, vacuum's applied to the top port here. It lifts this diaphragm and allows auxiliary air to flow from one side of the throttle plate to the other. This stops the engine from stalling on deceleration. Now the rate that this happens is adjustable with this lock nut. Loosen the lock nut using a 7mm wrench. We can turn this out or turn this in to limit how much and when this actually happens. So to test it first, I'm just going to blow through the bottom, and it should be closed with no manifold vacuum here. And it is. I can't get any air pressure through here. So to test it and make sure that it opens up, I'm going to apply my vacuum pump. And I've backed this setting off. I loosened the lock nut and I've screwed this fitting up a little bit. It's quite a large chamber, so it takes a little bit to get some vacuum pressure. You see how the vacuum gauge kind of moves up and down. And right now it's holding at 8 inches of vacuum, but it still won't allow us to blow through. So we're going to need to get up somewhere around probably 15 to 18 inches of vacuum to be able to blow through it. And then it closes pretty much immediately as it drops back down. So this unit is working, and we can screw it back onto our throttle housing. I'm going to install my new fuel injectors. C.I.S. fuel injectors are not a very cleanable item. They are more a service item that are designed to be replaced. A couple of things that will wear on them. Spray pattern will deteriorate, but one of the biggest issues is the cracking pressure. The inside here is a spring and shim arrangement, and it's designed to open up at approximately 3 bar. The K-Jetronic injectors will tend to start to drip when they fail, and that will result in a misfire on startup as it loads up the cylinder. So normally once injectors are at around 100,000 miles, I just arbitrarily replace, or when I'm doing an engine, I arbitrarily replace. I'm going to install new O-rings on our injectors. Lubricate with a little bit of silicone grease because these need to slide into our injector bucket. And then I'm going to take that and just press it in and seat it home. So on our airbox we have a plastic fitting, and this is a drain fitting, and it's connected using a 7.5mm hose down to our outside drain. And what this does on the bottom here has a little one-way valve, and this little rubber piece allows stuff to drain out but not come back up through. So if any fuel gets in there, moisture, anything gets into our airbox, it's designed to run down this pipe, out through this, and take it out of the engine, dump it out onto the ground. So I've just installed this thermocoupling vacuum valve. The purpose of this valve is to allow vacuum to flow, but only after a certain time period. So if I take my vacuum pump right now and pump it up, we'll see that it holds vacuum. Now the way that this works, this is an electrical connection that just plugs in on the back, like that. And this is connected to our warm-up regulator. Our warm-up regulator uses vacuum to change load sensing for the amount of fuel being delivered to the engine. This thermo time valve allows that load sensing to change by a set time period until the engine warms up a little bit. As this valve is electrically heated, once it gets to a certain temperature, it will open up and allow vacuum to flow through the system. So right now this valve is working correctly in that it is cold and it is not flowing any vacuum. So the last component that we have to fit is going to be our warm-up regulator. And we've touched on the warm-up regulator and what it does briefly. But basically what this does is it controls our cold fuel mixtures as well as our hot fuel mixtures. It also gives us some acceleration enrichment and lean running by these two vacuum connections. We'll go into a lot more testing on the running phase of this. For right now we're just going to bolt it on, and I want you to see where it's going to go. So this is just going to sit right here on the intake manifold for number 2 cylinder. Takes 2 long Allen head screws that hold that in and lock it down. Then the electrical connection, this is what heats the bimetallic strip. It's going to plug in on top, and that's going to be it. Okay, so I have our fuel line fittings which are basically the short side are going to be on our 4 through 6, and then these are just going to hook up around onto our fuel distributor. Now it doesn't matter which port an injector is connected to. They are continuous, so every port should be flowing the same amount, and they are always spraying, so don't worry too much about where each one physically goes. The main things we want to make sure is everything is clean, so no debris, and that we use a copper washer, a new copper washer every time, top and bottom, one on this side, one on this side, and we screw it in. Also have to be careful when we're tightening these, because they are hollow bolts, which means they are not very strong, and if you over torque them, you can break the bolt. So we've just got 2 wrenches, 12mm and a 14mm, and we're just going to tighten these down. These do not need to be super tight, just firm so everything seals. When you're using old injection lines, you are somewhat limited because they will take a set of where they want to go. So this one, I can see that these ones are going to kind of wrap around the back. So this is our warm-up regulator line, and runs from the fuel distributor to the warm-up regulator. So the last vacuum line that I have is going to come from our throttle body up here down to our warm-up regulator. This is a ported manifold vacuum signal. And what that means is the vacuum port is above the throttle plate. It's very small and hard to see. So if you are looking for constant manifold vacuum, it means that the hole needs to be below the throttle plate. If a hole is above the throttle plate, so on top of the intake manifold, that's going to be ported. That means that air needs to be flowing and the throttle needs to be open before it will begin to pull a vacuum on that line. So one thing we spoke about when we assembled the sensor plate onto the housing was setting our sensor plate height. And what that means is this plate will move up with airflow, but when it comes back down and is static, it needs to be sitting right at the base of this cone here. So right now this one is a little tiny bit low. Now we couldn't check it when we were rebuilding the airbox because it needs to have fuel pressure on it. Now we're on our test stand, we've got our fuel pump hooked up. I can run my pump, put pressure on our fuel distributor and check our height. So I'm just going to turn my fuel pump on and I can feel that I've got pressure. And I just want to pop it up a couple of times. And right now this one is a little bit low, so I'm going to go ahead and adjust it. So the adjustment on this one is controlled by this little lock nut and this little tiny screw right here. So I'm going to loosen off the lock nut and I'm just going to wind that screw up a little bit. Okay, so I just adjusted it up a little bit. I pulled it down first to move the lock nut out of the way. And now we can see the top of the plate is right at the top of that venturi. If I push the plate down a little bit, you can see that it just comes level with that venturi, which is where we want to do it. I've also still got fuel pressure on it because I've primed the system, so I can go ahead and check this as I do it. So I'm just going to lock up my lock nut, and that's our adjustment for our sensor plate. If the sensor plate is not set correctly, this will change the fuel timing in how much fuel is injected to the engine over the different RPM ranges. If the sensor plate is starting off down low, then the fuel timing is going to be retarded and it's going to run leaner throughout the range. If the sensor plate is starting off high, then the fuel timing is going to be advanced and it's going to be getting more fuel and creating a richer fuel mixture. So this is an important part of the step when tuning CIS. So when it comes to putting the boot on, you want to make sure that your hose clamps are facing the right direction. So I have them on the inside edge so I can get to them in the car as well as when the engine's on the test stand. The other thing to be very careful with is there's a tendency to pinch this boot because it is kind of tough to get this and this on at the same time. We've also got to go into our vent line right here, so I've got my hose clamp set for that. More so when it's in the car, it's a little bit tougher, and what you got to be careful is that the hose clamp doesn't fall off or twist, or that you pinch the boot and it's rolled over like this, especially when it's in the car, because that will create all kinds of drivability and running issues. And I generally try and work just one at a time. With the sensor plate, I've got a little hook tool that I use to help get it over the lip for me. This point and this point. These are hard to put pressure on, and this is where often the boot will be sitting up. So you want to make sure it's all the way down on this housing, especially when doing this job in the car. Before I start my engine, if I've had the fuel distributor off or the fuel system open, a quick way to get a rough base set on your mixture. I have a long 3mm Allen head or Allen bit, and that goes all the way down through the fuel head to the adjuster. I'm just going to turn the fuel pump on, and I want to adjust my mixture screw just till I get fluids just starting to come out of my injector line. So I've taken off one of my injector lines, and I'm just going to slowly and carefully increase that. And you want to go slow with these adjustments. Okay, you can see it's starting to come up, and there it is right at the top, just bleeding over. So that's usually a perfect starting point for a base fuel mixture setting. Now, this is not the final adjustment. This is just a base setting. There is no other way of setting these without a CO meter, at least a single gas CO meter in the tailpipe. Setting them up by ear does not work because the adjustments are so small. A turn literally this much can result in a mixture swing of 3 or 4% of CO. So you need to have a CO machine to set the final settings.